So we did this already. We've talked about this a bit. Finding these nth roots, nth root of a, not a whole lot that we haven't done already. This, yeah. So we talked about, might as well just go through this here. We talked about finding the nth root of a yesterday. So if I want to find the cubed root of negative 1,331, we know it has one real root. Cube root of negative 1,331. Negative 11. If the root is even, and we're taking an even root of a negative number, and for this here, we're mainly going to be focused on the real roots. So it does have a solution, and we did find ways to find it. We take the negative out as I, simplify, and solve. Rational exponents, we will talk about this more in chapter 5.2. It's just different ways we can apply roots and powers to be able to simplify and rewrite it. Because sometimes being able to apply the fractional exponent is going to be nicer than applying the power first, or applying the power first is going to be nicer than applying the radical. Because really, if we wanted to break it down and do this part by part, 16 to the 3/2, well, according to this, we can do it as 16 to the 1/2 cubed. And 16 to the 1/2, if we rewrote this as a radical, 16 would go inside. Our 1 on top of that rational exponent would go inside. 2 would go inside the v. So we're saying we're taking the square root of 16. Well, the square root of 16 is 4. And 4 cubed would be 64. So it gives us a way without a calculator to be able to factor these, simplify these down, and work them in a way that's going to be a lot nicer. Or 16 to the 3/2 is 64. So we can do it either way. And a similar thing can be done with 32 to the negative 3/5. To make that exponent positive, we move it from the top of the fraction to the bottom. And then we're going to split it up and say 32 to the 1/5 cubed. As a radical, 32 to the 1/5, if we write in radical form, the 5 on bottom of that fraction would go into the index. So we're saying we're taking the 5th root of 32 to the 1st power, or the 5th root of 32. And the 5th root of 32 we know is 2. To the 5th is 32, so the 5th root of 32 is 2. And 1 over 2 cubed would be 1/8. 32 to the negative 3/5 is 1/8. So it works, we can go either direction. But the big thing is important with this and doing this is that taking 64 to the 1/3 of the cubed root of 64 actually has a cubed root, that it actually will simplify. And for the most part, if we were doing this and I were doing this, first thing I'd check and see, does 64 to the 4/3 actually reduce? Does it simplify to something nice? It tells me it's 256. And if it starts giving me these irrational numbers, these non-terminating, non-repeating decimals, then we need to actually work it through and do the steps to be able to find out what it is in simplest radical form. Because otherwise, we can just take 16 to the negative 5/4, plug it in and see that it's 1/32, and we're done. It does it for us. Questions on this here? Now, the other main thing we're doing, because we're only doing real two big things today, is nth roots, solving by nth roots. Nth roots, this solving by nth roots is the exact same thing we did for square root method. And when we solve this here, the first main step is get the term to a power by itself. And we can do this if, in this case, we just have the variable to the fifth power by itself. We don't have x to the fourth, x to the third, x squared x. We don't have any other variables. X to the fifth is the only variable that shows up. Or the only place a variable shows up is inside a set of parentheses. So x minus 3 to the fourth, we can still do this here. Now, if we had x minus 3 to the fourth equals 21x, we cannot do this. Even on this one here, if it was 128x, it doesn't even have to be that. If it's just 128 plus x, we have variables other than that x to the fifth. We cannot do this. But since this here, we only have x to the fifth, that is our only variable. We can solve it by this method. And the first main step is to get that variable, that term to that power by itself. And well, right now the only thing with it is 4. So we're going to divide both sides by 4. 4x to the fifth divided by 4 is x to the fifth. 128 divided by 4 would be 32. Is the term to a power by itself? Well, yeah. Take the nth root of both sides. Take the nth root of both sides and follow our root rules. And what I mean by root rules are the ones that we had yesterday. If we take an odd root of both sides, we apply an odd root to both sides. We only have one real solution, one real root, one real root. It's just one real root no matter what happens. That's the nice thing about taking an odd root. However, if it's an even root, and what's inside is positive, we have two real roots. If it's 0, we have one real root, it's just 0. And if it's negative, we have no real roots. So at this point here, we're going to have to apply a root to both sides, and specifically, we're going to take the fifth root. And the reason we're taking the fifth root is we want to get that x term by itself. Now, the fifth root of x to the fifth would be x. What is the fifth root of 32? Fifth root of 32 is 2. And again, our root rule says we took an odd root of both sides, and the number inside there is greater than 0, so we have one real root. So the real root of the fifth root of 32 is 2. And lastly, step number 3. Solve for x. Solve for the variable. But for this one here, we're done, yes? Okay, so we solve for x. X equals 2. Okay, questions on this here? Fundamental theorem of algebra, the main piece that we cared about, not the fact that there's at least one solution in the complex plane for any higher degree polynomial function. But the corollary from it said that the number of solutions for any higher degree polynomial function is equal to the degree of the polynomial. Well, the degree for this is 5, yes? How many solutions did we find? 1. That means there's 4 other solutions, yes? But wait, what did it actually tell us to find? The real solution. 2 is a real solution for this here. It is actually the only real solution. It has 4 other solutions, but all 4 of those are in the complex plane. They are complex solutions. So we're done. We found the one real solution for this here. We're not finding the others. There are ways to do it, but a lot of that involves trigonometric formulas. Questions on this here? Let's look at the next one. X minus 3 to the 4th equals 21. Now for this one here, the first thing we need to do is get the term to a power by itself. Well, our term to a power in this case is our x minus 3, because it's to the 4th power. So we'd want to get it by itself first. However, there is nothing being multiplied in front of it or added to that sets of parentheses. Even though we do have that minus 3, it's still a part of our term to a power. So luckily for us here, the term to a power is already by itself. We don't have to do anything with it. So the first thing we can do is take the nth root of both sides. And the nth root that we're going to take is whatever the power that we have is. Since it's to the 4th power, we want to take the 4th root of both sides. Because on the left-hand side, our 4th root and 4th power would simplify, telling me that x minus 3 is equal to, well, let's see here, the 4th root of 21 is this irrational number. There is not a reduced form of this here. It does not reduce nicely. So instead of turning it into a decimal at this point, we will leave it as the 4th root of 21. But we do need to apply our root rules. Because we did take an even root of a positive number, we have 2 real roots. So that means that 4th root of 21 could be positive or negative. Questions on this here? And lastly, we need to solve for x. We need to get x by itself. And this one here, unlike the last one, is not by itself. What do we need to do? We need to add 3 to both sides. Negative 3 plus 3 would simplify, leaving x by itself. And again, whenever we add or subtract something, we do want to put it in front of the plus or minus. We want those numbers that we add or subtract to both sides to be in front of that plus or minus. Because really we have 2 statements there. We have 3 plus the 4th root of 21 and 3 minus the 4th root of 21. Now at this point here, we can say we're done as long as 3 and the 4th root of 21 will not be able to add together without approximating decimals. We already saw the 4th root of 21 does not reduce. So this here, as far as we have to take it. Because if I wanted to figure out what that value was, really we'd grab a calculator and say 3 plus the 4th root of 21. So one of the solutions is this here, 5.14. Bring it back down and change it from a plus to a minus, and see that the other is 0.86. 2 solutions. Questions on this here? What can we do first? We're going to divide both sides by 5. 5x to the 3rd divided by 5 is going to be x to the 3rd. 320 divided by 5 should be 64. What do we do next? Nth root of both sides, because the term to a power is already by itself, yes? Third root, x cubed is going to become x. Cubed root of 64 is 4. Since we took a cubed root of both sides, we're only going to have one real root, so x equals 4 is our only real root. And since it does not ask for all solutions, it's just asking for the real ones, this is the only real solution. Questions on this here? Do you feel comfortable with this so far? For this one here, I'm going to change it up a bit, just so we can say we've seen one. There we go. Not 8, let's go 16. Yep. Term to a power is by itself, yes? So we're going to take the fourth root of both sides. Left-hand side, the fourth root and fourth power will simplify, leaving us with x plus 3 is equal to, well, the fourth root of 16 is 2. Yes? But because we took an even root of a positive number, we have to add the plus or minus. Solve for x. We would subtract 3, telling us x is equal to negative 3 plus or minus 2, yes? And we can say we're done as long as I cannot take negative 3 plus 2 and negative 3 minus 2 and get a solution without approximating. Oh, wait. Negative 3 plus 2 we can do, yes? And it is negative 1. Negative 3 minus 2 is negative 5. Because I can simplify this, we can add and subtract those two. We have to add or subtract. So negative 1 and negative 5 are our real solutions for this here. There are two other solutions. They're non-real solutions. And again, the reason we didn't have to do it on the previous one is because the fourth root of 21 is an irrational number, non-repeating, non-terminating, so we'll just leave it here. There's not a whole lot of reason to simplify that down. Questions on this here? Do we need to see another example of one of these? Or do we feel good with these here? With 14, we could divide both sides by 1/2, or what else could we do? Because yes, dividing by 1/2 works. But multiplying by 2, 2 times 1/2 is 1. 512 times 2, we can actually do that in our head. It's easier to do that than. Now the fifth root of 1024. I'm going to have to say it's going to be smaller than 6. Is it 3? 4. That's it. Questions on this here? Really, that's it.